Ooh, a little bit off. I don't care what time my class closes. We keep on graphing. I'm gonna keep studying. I'm gonna keep doing my notes. Doing the same thing. Oh yeah. We gotta do our notes so we get smarter. Some of you need to just start doing your notes now. Oh, hey, sorry, I was just thinking to myself. Alright, well, here's your last section for 4-8, which means coming up soon, you've got a test. So, we need to know how we can solve real-life problems involving right triangles, solve real-life problems involving directional bearings, that's new, and solve problems using harmonic motion, that's new too. So what we're going to do is first thing is we need to learn how to solve a triangle. Anytime you solve a triangle, you need to find all three sides and all three angles. So whenever we're talking about angles, your angles are denoted with capital A's, B's, and C's. And whenever we're talking about the sides, those are little A's, B's, and C's. Now going along with this, big C is always the 90-degree angle. So keeping that in mind, what we're going to have to do is we're going to have to probably draw some pictures of triangles, and we'll be given some of these values, but then we're going to have to use SOHCAHTOA to help us solve them. So if we look here, example 1, we need to solve this right triangle. And unfortunately, they only give us A. Well, if it's a right triangle, they also give us big C, because C is going to be a 90-degree angle. So what we're going to do is we're going to draw on our triangle here. And let's see, let's go for a green triangle. So we go here, and over to here, and back up. So we get our right angle right here. We are going, and that's side C. A and B, it doesn't really matter. I always like to put A up top just because that's where I like my grade to be. I'll put B down here. Remember, side B is going to be across from angle B. So side B is going to be over here, which is 15. Now what we need to figure out though is we're going to figure out what side C is. We're going to need to figure out what side A is, and we're also going to need to figure out what angle A is. And angle A we know. We also need to figure out what angle B is. So angle A, beep, angle A is actually 20 degrees up here. And I want to write that in black. So this is 20 degrees up here. So what we can do, if we need to figure out what angle B is, and if we need to figure out what our side A and our side C are, we are going to be able to use SOHCAHTOA. So some of you may remember SOHCAHTOA, some of you may not, but we've been using it all chapter, so hopefully you all remember it. So is your sine of an angle is equal to your opposite over your hypotenuse. Ka is cosine of an angle is equal to your adjacent over your hypotenuse. And tangent is the tangent of an angle is equal to your opposite over your adjacent. Now this can only be used when you're doing a right triangle. So we need to look at a couple things we have. If we want to solve side A here, well, we actually have angle A and we have an adjacent side. So if we're going to try to find out what A is, we would have to use the angle A. So we're going to say the sine of A, big A, is equal to your opposite side over your hypotenuse. Well, we can't use sine then, because if we go opposite over hypotenuse, we have two unknown values. So if we use our opposite side and our adjacent side, maybe, or maybe we should label these. So from A, this would be our opposite side, this would be our adjacent, and this would be our hypotenuse. Then instead of using the sine of A, we can use the tangent of A. So we're going to say the tangent of A is equal to our little side A, that's our opposite side, over your adjacent side, which would be 15. So we can plug these values in. tangent of 20 degrees is equal to a over 15. And if you solve this equation for a, you're just going to have to multiply both sides by 15. So that means that a would be equal to 15 times the tangent of 20 degrees. So probably at this point though, your calculator is probably in radians. So since we are going to be in degrees, okay, 20 degrees, you need to make sure your calculator is back in degree mode. So otherwise it's going to give you, it's going to find 20 radians, which is a big difference from 20 degrees. So if we do this, we find out that a is equal to a 5.46. So there is one of our answers. 5.46. Alright, so now we need to figure out, well, we still need to figure out B and side C. B shouldn't be too difficult, because if we're trying to find out what angle B is, well, angle B plus angle A is equal to angle C, isn't it? Since we got a right triangle. Or I guess the way we could look at this would be, another way to look at it would be if you want to add angles A, B, and C, and those have to add up to 180. But keep in mind also, something you learned in geometry, that if you have a 90-degree angle, then A and B have to add up to that. So if we plug these values in, well, we don't know what B is. We know A is 20. C is 90 equals 180. So we'd say B plus 110 equals 180. B is equal to 70 degrees. So there is your side B. We may have wanted to figure that out at the beginning, but it doesn't really matter. Now finally, side C. Side C, we can find out side C if we know this leg and this leg. This is one way you could find out side C, is you could do a squared plus b squared equals c squared. You could also use any combination of SOHCAHTOA to find, as long as it had your hypotenuse in it. So you either have to use sine and cosine to find out what this is. It'd be a little bit more difficult. So what I'd recommend is just doing a squared plus b squared is equal to c squared. And when you do this, you find out that a is a 5.46 squared. Your b is 15 squared. And we're going to figure out what c squared is. So if you solve all this down, you should find out that c is equal to a 15.96. And since c is across from your hypotenuse, it should be the longest side. So it better be bigger than 5.46, and it better be bigger than 15. So that is how you solve a triangle. Remember, anytime you solve a right triangle, you need to find all three angles and all three sides. You can use any combination of things. You know, in this problem alone, we used SOHCAHTOA to find side A. We used just adding three angles up to equal 180 to find angle B, and then we used Pythagorean theorem to find out what C is. You could use different manners of finding these problems. There's no exact way necessarily that everybody has to do, but I thought I would just show you that wonderful little example and show you how to solve a right triangle.